me, just go ahead and put in this code. If you're already in my class, great, you can use that remind. Or on YouTube, there's a live chat there, so you have that option too. So we're going to get started, okay? So in my last live stream, what I did was I went through basically the skills that you would need to know. So we went through integration by U substitution, basic integration, integration by completing the square, and integration by long division. So all of those we went through. So if you need help on those skills-based things, go back to that. What we're going to work on today are more of the AP kind of style questions. Two types in particular that I want to look at, but they can ask you a lot of weird stuff. So I'm going to start with those. So again, at any point, send a question, ask a question, please. So this document I sent out to you guys before. We're not going to do all of these, but we will do a bunch of them just to get us started. We're going to start with kind of a more basic type. We'll move into some more difficult ones. By no means are we doing all 12 pages. These are just so I had options and you have extra help if you need it. Okay? So again, send questions as you need them. So I'm going to start with this one here. This is sort of the most basic situation you'll see. This is a very common AP style problem to see, where you see that you have a differential equation given to you. You are asked in part A for a slope field, in part B for an approximation, in part C for the actual solution. And you've done some of these on your review, and you've done them at other times. So this is what we're going to start with. So anytime I see this, that I'm given dy dx, to me, that signals that I'm given a differential equation, and I probably should think that at some point I'm going to separate. I don't always, but it's in the back of my mind. And especially on a test on separation variables, that would be important. So, part A says on the axes provided, sketch a slope field. You guys know the basics of slope fields. All you're doing is you're saying, okay, let me just try to take this and calculate my slopes, right? So something really important, the AP is not trying to fool you. Notice that this would be undefined, this differential equation, whenever your slope or whenever your x value equals 1. They don't even play with that on the AP. They're not trying to fool you. There are no points for you to do at 1. Do you guys notice that? At 1, there's actually no points on the graph. So when you're doing a slope field, only fill in on your points that are actually on the graph. So when I look at this, I'm going to just fill in these points. So at 0, 0, this would be 0 over negative 1. Notice that whenever y is 0, your fraction is going to come out to be 0. So I'm going to start by filling in those. And those are kind of my isocline for 0, because I know that whenever y is 0, that's going to come out to be 0. Then we really only have 4 points to evaluate. So at 1, so that's 0, 1 right here, this is going to be 1 over negative 1. So that'll have a slope of negative 1. This point here would be, I'm talking about this point. You guys can't see where I'm pointing. That point there would be 4 over negative 1, so that's negative 4, so that one's going to be very steep. I'm not looking so much that your slope is perfect, I'm looking for the relative steepness. So I'm looking that negative 4 looks much steeper than negative 1. That's the basic idea. Then I'm going to go ahead over to my other 2 points. So starting at this one right here, I'm plugging in 2, 1, so that would be 1 over 1, so a positive 1. And then I'm plugging in for this point 2, 2, so you're plugging in 4 over 1, which again should be a much steeper slope. So that's my slope field, and that on an AP exam is going to earn you probably 2 to 3 points, which is great. And on your test tomorrow or on Thursday, it will do the exact same thing. So part B is going to say, okay, now let's find the particular solution. So now I have these different an approximation. I have these points, I want to approximate with them. So let y equals f of x be the particular solution. Notice it does not say to actually find the particular solution here. Don't separate, just assume it is. I know this is my initial condition, so in your mind, kind of associate that with a point 2, 3, right? Write an equation for the tangent line at 2. So tangent line, I always want your mind to go, okay, point and slope, right? Point and slope. So my point is going to be y minus 3 equals blank x minus 2. And my slope, again, remember, is your derivative, so your differential equation. So my derivative at x equals 2 is going to be, well, we're going to plug in the point 2, 3, right? So 2, 3. So my slope here, I'm going to plug this in, is going to be 3, which would be 9 squared, over 2, which is 1. Or sorry, 3 squared, which is 9, over 1. So your slope there is 1. So what we get here for my value is 1. So take a look at that. Make sure you feel okay about that. Okay. So again, my slope there is 9 because I'm using the point 2, 3. And then it says use this to approximate f of 2.1. So I am going to plug 2.1 into this. Now, on the AP exam, you did not have a calculator for this. On the test tomorrow, you may or may not. So y minus 3 equals 9 times, and I'm plugging in 2.1 minus 2, so 0.1. You need to be able to do 1/10 times 9. Yeah, Harry, you can totally ask a question on the review sheet after this. So y minus 3 equals 9 times 0.1 would be 0.9, right? Add 3 to the other side, so this would be 3.9. So what I know is that f of 2.1 is approximately 3.9. So there's two parts of this answer that I'm looking. I'm looking for a correct tangent line. Number 2, I'm looking for a correct approximation. Okay? All right, and now we're going to do part C. So on part C, I'm looking to find this solution. And anytime I actually want to find the solution, we're doing separation of variables. So I have dy dx is y squared over x minus 1. So dy dx equals y squared over x minus 1. And my initial condition is 2, 3. So I'm keeping that in mind. So very, very important on our test and on the AP, and I will be just as tough as the AP on this. If you don't show me the step where you separate your variables, you are not eligible for any of the remaining points. On this particular question, that means you are ineligible for 5 out of 9 points. So make sure that you show that step. So separating these variables, I know the dx is going to have to come over to this side, right? Multiply it up. And I know this y minus 1 is going to have to come over to this side somehow. So I'm going to divide by y squared, so dy, equals, now multiply over by dx. So there's my separation of variables. And that's, again, the big step you have to show. And then I'm going to integrate. And be very careful with this. Make sure when you integrate that you're not just being ln happy. I'm only doing ln if I have 1 over something to the first power. So on this one in particular, this is really the integral of y to the negative second dy, not to the negative first, right? Now this one on this side, on the right side, that is 1 over x minus 1 to the first. So that is ln of absolute value x minus 1 plus c. So now make sure we integrate the left side. Go up a power, so that would be to the negative first. I need that negative 1 to cancel, so I'm going to throw a negative 1 out front. And this is going to be ln absolute value of x minus 1 plus c. So take a second, digest that. Make sure you're okay with that. Again, send questions if you have them. So now I need to solve this for y, right, to get my particular solution. So solving this for y, I'm going to actually rewrite this as 1 over y is ln absolute value of x minus 1 plus c. It's just easier for me to solve. So I'm going to actually take that negative and move that over to the other side, right? Divide both sides by negative 1. And now I've got 1 over y equals that over 1. So what I'm going to really do is make this y equals 1 over negative ln x minus 1 plus c. So that there is my general solution. Okay, that's my general solution. So now to get my actual particular solution, I just need to solve for c. So plugging this in, I know I'm plugging in 2 for x and 3 for y. So I would have 3 equals 1 over negative ln of 2 minus 1 plus c. So here I'd have 3 equals 1 over, that's not going to change, ln of 1 is 0, so that's just c. So solving that for c, c would equal 1 over 3. I cross multiplied, divided. C is 1/3. So your particular solution here is y equals 1 over negative ln absolute value x minus 1 plus 1/3. And I don't care if you leave 1/3 in there. It doesn't bother me. That's a totally fine particular solution. Okay, so that solution is my particular solution there. Okay, if there's any questions on that one, send it. But that's kind of the most basic. We're looking at the fact that this is, separable, and then we can separate it. Okay, go ahead and send those review sheet questions now because I don't know what they are right now, and I'm a little ahead of you in real time. So I'm going to just go on to another question, but once you send those review sheet problems, I will go to those, okay? So let's go on to this one because this one's a little bit different. Okay, this one's a little bit different. So on the axis, sketch the slope field. Again, just plug in your values. So plug in your values for the slope fields. I'm not going to spend a lot of time on that one right now. But again, they're not trying to fool you. Excuse me. Only plug in at values where there are points. There are no points there. Don't plug in. Okay? Now, part B is really important here. So it says, find the second derivative in terms of x and y. So this is my first derivative. So let's find the second derivative. So second derivative here, I know dy dx is 2x minus y. Okay, so my second derivative, I'm just going to take the derivative of this. So that's going to be d squared y over dx squared equals derivative of 2x. Again, we're taking this with respect to x, so make sure you're just taking it with respect to x. Derivative of 2x is 2. Derivative of y with respect to x is dy dx. Right? It's like when we do related rates. Y is a function of x, so I need to take the derivative of that with respect to x. Now, that is your second derivative, but that is not the second derivative with respect to x, or in terms of x's and y's. So I'm actually going to plug back into this. So my second derivative here would be 2, that's fine, minus, and now I'm going to plug in dy dx, which is this. So that's going to go in where dy dx was. So minus 2x minus y. And so this is really 2 minus 2x plus y. So that is sort of the first main objective, to get that in terms of x's and y's. Okay? So the next thing that I want to do is answer the next part of that, which says, determine the concavity of all solution curves in quadrant 3. So let's think about quadrant 3. In quadrant 3, I know that, let's see, my x values would be negative and my y values would be negative. And that is a y, right? So both of those are negative in quadrant 3. So think about this. If you are doing 2, negative 2 times a negative plus a negative, right? Think about what that would give you. Okay, just take a second. Think about what that would give you. I'm just reading a couple messages people sent. Okay. So, did it say quadrant? Oh, it said quadrant 2. Quadrant 3, we couldn't determine this. In quadrant 2, I have negative y and positive x. Okay. So negative y and positive x. So I'm doing 2 minus a negative. So this is going to be plus, right? 2x plus y. And I know that those are all positive, right? So here's the thing. Since we know that x is less than 0 and y is greater than 0, d squared y over dx squared is always going to come out being positive. Thank you for saying it's quadrant 2. Okay, it's always going to come out being positive. So if it always comes out being positive, that means, right, that implies that y is always concave up. I can't even spell tonight. In quadrant 2. Okay, in quadrant 2. So again, second derivative being positive implies that it's concave up. So that's part B. Okay, so determine the concavity of all solutions. Y will always be concave up in quadrant 2. Okay, so this says, let f of x be a particular solution. Notice it does not say to find the particular solution. It says assume it is, right? With this condition, so I know at 2 it equals 3. Does this have a relative min, a relative max, or neither at 2? Well, I don't have the function. So let's think about how we would figure this out. So I know that my first derivative is dy dx is negative 2x minus y, right? So let's figure out what dy dx is at that point. So at 2, 3, right, that's my condition that I'm using. Dy dx would be 4 minus 3, which would be 1. Right? 4 minus 3, which would be 1. Okay? Since this equals 1, your derivative equals 1, that value, 2, x equals 2, is not a critical value. And if it's not a critical value, therefore, it cannot be an extrema. So that is not a max or a min or anything. Okay, it cannot be an extrema. All right, we're going to skip part D for now because that's something that's a little bit outside the realm of what we need to do right now. But that's part A and part B on that one. That one's a little bit tougher. Okay? All right, I just got a couple good questions on the chat, so we're going to take a pause for those. So the first question that I got on the chat was, how do I know when to use a U-sub? And I talked about this a little bit in the last, I talked about this a little bit in the last video, but, add page. Okay, a little bit in the last video, but this is something that if you have questions about, go back to the last video. But U-sub should tell you that it's function composition, and U-sub should tell you that you see its derivative in there. So like if I see the integral of cosine x squared dx, is that function composition? Absolutely, right? I see a function in a function. But do you see the derivative of x squared in there? Because I don't. So that is not a great candidate for U-sub because I don't see both things. If I gave you this, then I could say, okay, well, that's function composition. It's a function and a function. And there's x squared. There's the derivative of it. Even if I saw the integral of x cos x squared dx, right? So this is x squared. This is a multiple of its derivative, right? Its derivative is 2x. That's a multiple of it. So that's totally fine. That doesn't bother me, okay? That's how I would know to use U-sub. Again, if you need more help on that, go back to the last live stream. All right. The other question that I got was this one from the packet, which was the integral of 1, I think it was 1 plus sine x over cos squared. So the first thing that a lot of people want to do on this is they want to see this and go, oh, that's cos squared, right? It's not. It's not squared, and if it was, it'd be 1 minus sine squared. So that is not a trig identity that we know, okay? So the only thing I can really do here is try to think, well, maybe it's a U-sub. So let's say I made this my u, right? I made that my u. So that would be 1 plus sine x. The derivative of that would be cos. That derivative on its own is not in here. And cos squared is not a multiple of that. So that won't work. Maybe I make it u into cos, right? Then the derivative of that would be sine, not 1 plus sine. So that's not great. This is not a great candidate for u sub. So what I'm going to think about then is an algebraic simplification first. So I'm going to make this 1 over cos squared plus sine over cos squared. So no calc here. That's just pre-calc, right? But break that up into those two pieces. So now this would be the integral of 1 over cos squared is secant squared plus sine over cos squared is really, think about this, as sine over cos times 1 over cos, right? Sine over cos is tangent. 1 over cos is secant. So this is really what I'm integrating, dx. And now this is just a straight antiderivative. So the integral of secant squared is the derivative of tangent plus the integral of tangent x secant x. Well, that's the derivative of secant x plus c. So this would be my antiderivative. Okay, I got a question on how would I do this top one, this first one that I said. That is one we don't know how to do as of yet. So hold for more information. That's something that you would get into later in your calculus journey. Okay. All right. Keep sending questions until I get more. I'm going to keep going on what I had planned. Okay. So we're going to do another one that looks like this, and this one involves a slope field. Okay. This one involves a slope field. And we're going to go ABC through this. And then we're going to get into some more like application-based ones, like the word problems with the, dumping or the potato or whatever. So consider the differential equation. Hey, they tell you it's a differential equation. That's good. F is a particular solution with initial condition f of 0 equals 1. Okay. It's defined for all real numbers. That's great. That means I know it's never going to be undefined. So a portion of the slope field is shown. They gave you a pretty massive portion. And they want you to sketch the curve between 0 and 1. So what we're going to do here is we're going to kind of connect the dots a little. Each of these little segments, these little linear pieces, shows me what the slope of my curve would be at that point. So 0, 1 is where I'm going to start because I know that that is part of my solution. So at 0, 1, I see that my slope, and I should close that out. At 0, 1, I see that my slope looks like that. So that's where I'm going to start. From here, you are following the curves. So I'm going to follow the curve here until it gets to the next slope line. And that gets a little steeper, so I'm going to make my curve a little steeper. Then I'm going to follow it up a little more. Okay, that gets a little steeper. I'm going to follow it up a little bit more. I'm going to keep following that up. And, it kind of levels out here, right? And then there it starts to come back down. And so you start to see what your curve looks like, okay? I'm going to keep going on the other side. So follow this. Okay, it gets a little steeper. Gets a little steeper. Again, you're not going to be perfect here. You're tracing. Everyone's might look a little different, but that's okay. This starts to level out, and then I see that it turns, starts coming back up. And so that's what I would expect it to look like, okay? It doesn't have to be perfect, but I want it to look something like that. So that right there, let me check on the actual rubric. That right there was worth a point. So that got you a point, okay? Okay, so the next part says write the equation for the line tangent. Notice that comes up a lot to the curve and use it to approximate f of 0.2. Okay, so I know that this is my initial condition. I need a point, I need a slope. That is my point, okay? So I also need a slope here. So my slope is going to be based on dy dx. So I'm going to plug in that point to my slope. So 0, 1. So it's going to be 3 minus 1 times cosine of 0. I need you, begging you, please know your exact trig values, okay? Do not rely on having a calculator for those. Please make sure. So this would be 2. Cosine of 0, think of where that is on the unit circle. That's over here. Cosine is your x value, so that's 1. So dy dx at that point is 2. So what I have now is y minus 1 equals my slope times x minus 0. Do you have to write the x minus 0? No. Does it hurt you? No. And I would leave that in point slope form. I would not change it. That to me, boom, is a point. Okay, you've got that. All right. So then I would say now find f of 0.2. So I'm going to plug that in. So y minus 1 equals 2 times 0.2 minus 0 is 0.2. Yes, you need to be able to do that without a calculator. So y minus 1 equals 0.4. So y would be 1.4 here. So what I know here is that f of 0.2 is approximately 1.4. That's the other part of your solution. Okay? Now, the last part we have is find y equals f of x. This is find the particular solution. So, finding this, all right, this was my differential equation. dy dx is 3 minus y. If you can hear someone talking in the background, Mr. G is also live streaming right now because we're nuts. So we're going to separate this, right? If you do not show me the separation step, I cannot give you any credit for this entire section. So please make sure you show it. Okay, so I'm going to separate my variables. This is going to be 1 over 3 minus y equals cos x dx. And I almost forgot my dy. Don't do that. Okay, separate your variables. Integrate both sides. We are going to be careful with this one. Okay, this looks like, oh, ln of 3 minus y. But remember that what I'm really doing there in my head is a u substitution. So u here would be 3 minus y. du is negative 1 dy. So you have to be careful here because of that negative. So I actually would be subbing in negative du for dy. And so this becomes the integral, negative out front, of 1 over u du. So when you actually take this integral, it should be the opposite of the ln of 3 minus y. Okay, be very careful with that. If it's just y minus 3 all day, ln, have a blast. But if it's 3 minus y, be careful with the negative. Okay? Integral of cosine. So stop and think to yourself, what has a derivative of cosine? So it's cosine is the derivative of sine. Sine derivative is positive cos, so this is just positive sine. Please look at the positives and negatives on your trig derivatives, okay? Please look at those. I have some people who consistently mess that up. You know who you are. Make sure that you're looking at that. Plus c, okay? So that's my general antiderivative. It's just not solved for y. So now I want to get y alone here. So I'm actually going to do something first. I'm going to get the ln alone. So I'm going to move that negative over to the other side. And you can make this minus c, but it's still a constant, so I'm going to leave it as plus c. So now you can do e as your base for both sides. So this would be absolute value of 3 minus y equals, e to the negative sine x plus c. I can get rid of the plus or minus as soon as I bring down this c e to the negative sine x. If you need more help with like when can I do that, when can I not, go back to my last live stream. I did a bunch in there, okay? So now I just need to solve for y. So I'm going to actually add the y to the other side and subtract the ce part over. So it'd be 3 minus ce to the negative sine x. So that's your general solution, not what it asked for. So particular solution here, I'm in my initial condition. So 1 equals 3 minus ce to the negative sine of 0. You have to know your trig values. So over here, looking at this baby, this is 0 degrees, okay, or 0 radians. Sine is your y value, so that is just 0. So this is 1 equals 3 minus c, right? So c equals 2. So your final answer here would be y equals 3 minus 2e to the negative sine x. Now, let's say you didn't bring the c down to the front. Okay, let's say you didn't do that. Maybe you left it like this. Y equals 3 minus 2, or minus, sorry, e to the negative sine x plus ln 2. Maybe you had that. That's the same thing. That's equivalent. You would still get full credit for that on the exam. Okay, please continue to send questions if you guys have them. I have no problem going over whatever you guys have to ask. All right, next one. What do I want to do next? All right, before we get too far into this, because we've already been on for about a half hour, I want to look at another application problem. And I'm actually going to pull back up that potato problem that we did. And that is almost impossible to read. Okay, hang on. We're going to remedy this. I am going to pull this up. Hold on a second. I just need to save the file. Okay. So the big thing with these is they may not always say it's a differential equation, but if they're giving you the derivative, it's a differential equation, right? And so what you need to be careful of is, do they actually want you to find the particular solution, or do they not really care, right? Do they not really care about it? So let me just let this refresh. Here we go. Okay, this is last year's free response questions. And the reason that I'm looking at this potato one again is because it's kind of unique in what they asked. It's very unusual. Normally, like what we've been doing is pretty typical for the AP exam. So I'm just opening up this question again because it's a pretty unique one, but it's the direction they've been going in the past couple years. So I would say expect to see something hauntingly similar to this tomorrow. I don't know. So not a bad idea to make sure you understand this. So I'm just going to open this up. All right. So all these questions about bananas, about potatoes. So this is the potato, okay? So at t equals 0, a boiled potato starts on the stove. The internal temperature is 91 degrees. They're giving you an initial condition there, right? This is your initial condition, okay? The internal temperature of the potato is greater than 27 for all. T greater than 0 might be helpful later. And this is dH dt. They don't need to tell me that that's a differential equation. They do, but they don't need to because that is dH dt. It's a derivative, right? So now what I want to do is look through this. Notice what's popping up again. Tangent line. So write the equation for a tangent line at t equals 0. Use this equation to approximate the tangent line at, or the value at 3. So I need dH dt first. So let's start with a point. I know it's 0. What is h? Because remember, it's h in terms of t. What is h for that time? Well, it's 91. Right? They tell me that. And so to get this value, I'm going to plug this into here. So it would be negative 1/4 h minus 27. Okay? So 91 minus 27 is 64. And so negative 1/4 of 64. Again, this was calculator active. So that would be negative 16. Okay, my class, you've had this question on a test before. So y minus 91 equals negative 16. So, tangent line, that's it. That's all I want to see. Again, the 0 can be there or cannot. I don't really care. That's up to you. But now I need that to approximate t at 3. So, y minus 91 equals negative 16 times 3, right? Multiply 16 by 3, it's negative 48. Add 91 over there. So y would equal 43 degrees. So your potato is cooling off. It is now 43 degrees. Check your units, right? You need units on your answer. This would be 43 degrees Celsius. So that's my approximation. And I could say here that h of 3 is approximately that value. Okay? Now, use the second derivative to determine whether this is an overestimate or an underestimate. For the sake of time, and we could find the second derivative here, but you would just be doing this derivative right there, derivative of that. I just want to look at what happens here. So let's pull this down to here. So second derivative. You should always, when you see second derivative, think about concavity. So if the second derivative is positive, that means that this function h would be concave up, right? Think about what that looks like. If h is concave up, then the tangent line is below that line, right? And so the tangent line is under, so this would be an under approximation, okay? If it's concave up, the tangent line is below, so this would be an under approximation, okay? If the second derivative was positive, is negative, then h would be concave down, right? This is all like cause and effect. Just think about what that means to you. And if that's true, looks like this. The tangent line is above, right? Which means that this is an overestimate. So that's what I would be looking for in a problem like Part B. Okay? All right, Part C then says, using an alternative model, this is my differential equation. It says, find an expression for G. It does not say, find a particular solution. Do you notice that? It says, find an expression for G. But they gave you the derivative, so you need to be able to work backwards, okay? That's what you're looking for. So I'm going to separate this. So separating this, I'm going to divide by this G term. So G minus 27 to the 2/3 dg equals negative 1 dt. Integrate both sides. And this was a tough integral. We did this in class. It was tough. The integral on the right side is just negative t plus c, right? The integral on the left side, so I need to think of this as being g minus 27 to the negative 2/3. Okay? When we integrate that, think of your u as g minus 27. Your du, luckily, is just dg. So this is the integral of u to the negative 2/3 du. Go up a power. This is power rule. So this would be u to the 1/3, right? 2/3 plus 1. Negative 2/3 plus 1. You need a number out front to cancel. Multiply by the reciprocal of that. And then I know I don't want it in terms of u, so it would be 3 times g minus 27 to the 1/3. Okay? So, I want to solve that for g. If you wanted to solve for c here, you're welcome to, but I'm going to solve for g. So I'm going to multiply through by 3. So g minus 27 to the 1/3 is negative 3t plus 3c, which is c. And then I'm cube rooting that, so I'm going to cube it. So g minus 27 is negative 3t plus c all cubed. Now, I want g alone, so I'm going to add that to the other side. Okay? And that's my general solution. So to get my particular solution, I need to plug in my initial condition. And they told me in this that this was also 0, 91. So doing that, 91 would equal 0 c cubed plus 27, right? So 64 is c cubed. So c, cube root it, is 4. So my particular solution here is g equals negative 3t plus 4 cubed plus 27. That was most of the points. Based on that, find a value at 3, so then you would substitute it, okay? You just have to recognize what it's asking, which is really the same as the other problems we've done. It's saying, find a tangent line, find the particular solution. Okay? All right, we're going to do 10 to 15 more minutes, Send me any last questions or things you really want to go over. I'm happy to do it. But otherwise, I'm going to go back to the questions I was looking at and try to pick another one that I think would be helpful for you guys for tomorrow. So let's look at the last one. Okay. So, we did that one. We've done one like that. Okay. Let's look at this baby bird one. Okay, the rate at which a baby bird gains weight. This is another kind of application one. So the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. Okay, proportional to the difference. They give you the differential equation. So, number one, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Is it gaining weight faster? To me, says you're looking at a rate. So, rate derivative, right? So, that's what I'm going to start with. I'm going to say dB dt equals 1/5 times 100 minus 40 grams. That's my first, right? So that's 60 times 1/5. 60 divided by 5 is 12. So that's dB dt at 40. And then I can plug in 1/5, 100 minus 70. So that's 30 over 5, which is 6. So I see that my rate is higher when the weight is 40. So it would be gaining weight faster at that time. Okay, so when your derivative is higher, it's gaining weight faster. All right, find the second derivative. Use this to explain why this cannot resemble the following. So here's what I'm going to do. I'm going to find it. So t is 1/5 times 100 minus b. Okay, that is 20. That just tweaked out. Minus 1/5 b. And I want the derivative of that. So d squared b over dt squared is derivative of 20, 0. Derivative of this is negative 1/5. Now I'm taking the derivative of b with respect to t. So dB dt. Okay? And so that's going to be negative 1/5 times what I already know dB dt is, which is 1/5 times 100 minus b. Okay, so why can't this resemble the graph? So let's think about this. If I plug in a value here, right, at any of those ones we just did, when I plugged in 40, when I plugged in 70, the dB dt came out to be greater than 0 for a bunch of those values, right? And if I multiply by negative 1/5, that's going to wind up being positive, or negative, sorry. So since your second derivative, d squared b over dt squared, is negative wherever when b is less than 100, that means my function would have to be concave down there. And if I look at this, my function is concave up. So that would not work because my function's concave up. Again, this is kind of a difficult one, but the idea of the concavity. All right, and then the last one, use separation of variables to find this. Okay, let's do it. So I've got 1/5 times 100 minus b. So I'm going to do 100 minus b divided over to the other side with db. And then I'm going to do the 1/5 and the dt. So now let's separate, or let's integrate. So this is going to be ln of 100 minus b. And remember what we said before, because these are kind of reversed, your b has a negative coefficient, you need that negative out front, and it's because of this. Your u here would be 100 minus b. Your du would be negative db, negative 1, right? So you'd be plugging in negative du for db. So that's where that negative comes from, okay? So then I know that equals 1/5 t plus c. Okay? Now what I'm going to do is I'm going to solve for y. So again, I'm going to move that negative over to the other side just to make my life easier. So negative 1/5 t plus c. I'm going to make e the base of both sides. So this would be absolute value of 100 minus b equals e to the negative 1/5 t plus c. I can get rid of that absolute value when I bring the c down to the front because that could be a positive or a negative. And then I'm going to solve for b. So b would equal 100 minus ce to the negative 1/5 t. And what they asked me to do is find that particular at 0, 20. So again, 20 equals 100 minus ce to the 0. So c has to equal 80. So your particular solution would be y equals 100 minus ce to, or I'm sorry, not c, 80 e to the negative t. And that's your particular solution. That is a particularly difficult example. But again, something you guys would be totally capable of, I think, if you got enough practice. Okay, any last questions? We've been on here for almost an hour. So I'll take your questions, send them away. I'm going to give it like 5 minutes. If you guys don't have questions to send me, please just ask anything. Whatever you have, think about it. And we're leading at halftime in the basketball game right now. So that is good. I'm going to eat my dinner while you send questions. Anything. The whole test is calculator active tomorrow. Good question for those of you that asked it. The whole test is. Bring your calculators. Make sure they're charged. What else? Yeah. Okay, so somebody said, could I do a PERT problem, a KEKT problem? So here's the deal with those. They don't come up on the free responses a lot on the AP exam. So that's why there isn't one here for us to do. But I'm happy to do one. So looking at that, anytime you see this, you see dy dt or df d whatever. Let's use weird variables. If I see df dt is k times f, that to me signals that if I separated those variables, I would get f equals c e to the k t. So if you're given that, don't even go through the separation. You don't have to. You can, but you don't have to. So I'm just going to jump right to this. So let's say, well, you also could see this. It's directly proportional to the rate of change. So the rate of change is directly proportional to the quantity. That's the other way we would say that. Anytime you see one of those two things, go right to PERT. Okay? So let's say I gave you something like this. The rate of change of bacteria is bacteria growth, right? Population growth. dB dt is K times B. So it's directly proportional to the number of bacteria. And I know that it starts with 300 bacteria. Okay? And after 2 hours, it doubles. So let's say that's our problem, right? So this is what I know. As soon as I see this, I'm going to go to, okay, CE to the KT. And actually, I don't even want to use Y. I want to use B. So remember that this is your initial, right? In PERT, that's your initial investment. So it's going to be B equals 300 E to the KT. and I need to solve for k. I don't know it, right? T is a variable. T is our independent variable, but I need k. So I'm going to use my other value that I know, which is after 2 hours, it doubles. So this would be the coordinate 2 hours. There would be 600. So 600 would equal 300 e to the 2k, because time is 2. So divide both sides by 300. 2 is e to the 2k. And then take a natural log of both sides. So ln of that whole quantity. So this is ln of 2 equals, ln of e is 1. This 2k comes down to the front. So k is ln of 2 all over 2. So my solution to this, if they just said find the particular solution, would be 300 e to the ln 2 over 2 t. That is your particular solution. Now, they could go a step further and they could say, okay, how many bacteria would there be after 10 hours? And all you would have to do is say, okay, the number of bacteria would be 300 e to the ln 2 over 2 times 10, right? That really is the KEKT, the PERT stuff that we're doing. Anytime you see one of these two things, either in words or symbols, go right to this. Okay. Similarly, if you saw this, I might go right to one of these. So let's say I told you that y equaled 10 e to the 12t, right? And I might want to know what's the rate of change at when there are, so let's say maybe it's the same scenario where this is 300. And k was ln 2 over 2. So same equation. Let's say I say, what's the rate of change? How fast is B changing when there are 1 million bacteria? So I could take the derivative of this and plug in 1 million for the bacteria, but I would need to figure out at what time that happens. So what I could do here is I could say, okay, this means that dB dt equals k times B. And that would be k that I solved for times B, which I told you was 1 million bacteria. So you can go both ways. That's much less common. This way here, going to there, is how you'll normally see it. Okay, last questions. What else do we have? One thing I'll remind you guys, remember that I'm picking harder questions to do on some of these. I'm picking tough ones. I want you guys to be challenged now. The stuff on the test should look easier. So if you're looking at like the baby bird one and going like, the world's ending, it's okay. I'm doing tough stuff now so that tomorrow, if there is something tough, you've seen something. And if it's not tough, great. Anything else? Okay, I will still be up, so send me questions on Remind, take a picture of it, send it to me. This video will be up all night. Feel free to fast forward, rewind, and all the keys to everything are on my website, okay? The last review session link is on my website. This link will be on my website, and I think it's a very fair test, so I think you guys are going to be in good shape. Just make sure if you have questions, you get them answered before the test. I'm also off 1-2 tomorrow, so if you want to come in during 1-2, I'll be in my room, okay? I hope you guys have a great night. Bother me with any other questions you have. It's why I'm here, and I'm going to go eat dinner. Okay, have a good night, guys.